Welcome to IEDs. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
When we think of combat zones, one of the most lethal threats that soldiers face isn't just bullets or shrapnel, it's blasts. Whether from improvised explosive devices, artillery shells, or rocket attacks, explosions can unleash devastating pressure waves that tear through the air, causing traumatic brain injuries, internal bleeding, and sometimes fatal organ damage. Protecting troops from these invisible but powerful threats requires far more than just thick walls. It demands a revolution in how we design the shelters they rely on. The challenge is that most traditional military shelters and vehicles were built with ballistic protection in mind, meant to stop bullets or fragmenting shrapnel. But blast waves behave very differently. They don't just puncture or penetrate, they ripple and crush, creating forces that can collapse structures or incapacitate soldiers with a single wave of pressure. And while current shelters are certainly tough, many are heavy, bulky, and not specifically engineered to deal with the high-speed, high-pressure effects of blasts. That's where cutting-edge materials come in. Engineers are turning to advanced composites and polymers that don't just resist damage, they absorb and redirect explosive energy in smarter ways. Take carbon fiber composites, for example. These materials are incredibly strong for their weight, meaning they can be built into shelters that are both protective and portable. When a blast wave hits, the structure can flex slightly to absorb the impact, rather than crumpling or cracking. That kind of flexibility is key not just for protection, but for maintaining mobility in the field. Then there's aerogels. They might look like fragile foams, but don't be fooled. These ultra-lightweight materials are some of the best shock absorbers known to science. When lined inside a shelter, they create a cushion against blasts, dampening not only the force of the pressure wave, but also the searing heat that can accompany explosions. Aerogels act like thermal and shock insulation in one, offering a double layer of defense for soldiers inside. Another breakthrough comes in the form of shock-absorbing polymers. These smart materials deform under pressure in a controlled way, absorbing energy and spreading it across the structure instead of letting it focus in one destructive point. These polymers can help shelters bounce back after a blast, often with minimal damage, which means fewer repairs and more consistent protection in the field. But material science is just one part of the equation. The modern battlefield demands speed and adaptability, and that's where modular design comes into play. Today's shelters aren't just static bunkers, they're dynamic systems. Modular blast-resistant shelters can be assembled quickly, reconfigured based on mission needs, and even expanded or compacted depending on the environment. That flexibility is crucial in fast-changing combat zones, where the threat landscape can shift in a matter of hours. Looking ahead, the future of blast-resistant design is incredibly promising. Engineers are already working on next-generation shelters that monitor internal conditions in real time, adjusting ventilation, pressure, or even structural stiffness based on nearby threats. Imagine a shelter that can detect a nearby explosion and adapt its configuration within milliseconds to better protect its occupants. In the end, protecting soldiers from blast threats isn't just about stronger walls, it's about smarter engineering. By combining high-performance materials like carbon fiber, aerogels, and polymers with modular, responsive design strategies, the military is building the next generation of shelters that save lives. In a world where threats evolve rapidly, so must our defenses, and thanks to advances in material science and engineering, those defenses are getting better every day.